Okay, good evening. December 23. Is it 23 now or 24? Merry Christmas to everybody. This is Professor David J. De Los Reyes. I will now be trying to continue my lecture on differential equation. And the topic for tonight will be differential equation DE38. Okay, let's proceed, guys. This is now lesson number DE38, second order differential equation. Since I discussed already the concepts on how to solve a second order differential equation, I will now try to give you an example problem, second example problem on second order differential equation. Okay, let's proceed, guys. This is a long video. This is example number 2 under second order differential equation. The given second order differential equation is given by the equation d square y over dx square plus 3 dy dx minus 4y equal to 0. This is a second order differential equation. SODE. Okay? Second order differential equation. The total number of times, the highest, in which the given differential equation was differentiated is actually 2. Okay? So the order of the differential equation is actually 2. The order is actually equal to 2. That's why our topic for tonight is second order. Okay? The requirement of the problem is find the general solution. I've discussed the solution under DE35, and there are actually 3 general solutions for a second order differential equation. Okay, I will discuss briefly. Case number 1, if the roots m1 and m2 are unequal and both real, that will fall under case number 1. Under case number 2, if the roots m1 and m2 are equal and real, that will fall under case number 2. And under case number 3, if the roots are real and are complex numbers, it will be an alpha plus j beta and alpha minus j beta. That will fall under case number 3. That is the worst case scenario under second order differential equation, meaning the solution is actually a complex equation. Okay, hold on. I just check my camera, guys. Okay, let's proceed with the solution. We'll make the solution as brief as possible and as concise as possible, so there will be no magic. Okay, let's proceed with the solution. The solution is something like this. We need the representation. Actually, we will let y equal to a certain constant k, e raised to mx. Okay? Let's try to take the value of dy dx. The value of dy dx is equal to the derivative with respect to x of y, right? In order for us to take dy dx, it will be equivalent to the differential with respect to x of y. But what is y? Y is this one. So I place it here, dy dx equal to, okay, the derivative with respect to x of k e to the mx. It will be, this is a constant exponential function, so it will be that constant times the differential of that exponential function. Okay, constant times a function. It's the basic differentiation, right? So this will be k the differential of the exponential function is actually e to the mx times the total differential of the exponent. The exponent comprises of m and x. M is constant and x is variable, so if we try to take the differential of this, it will be m times the differential of x with respect to x. We are differentiating with respect to x, so this is times 1. Okay? So what comes out for dy dx will be equal to km e raised to mx. K times m is km times e to the mx, that's dy dx. Okay? So we now know the value of this one. Right? And so with this y here. Right? So we are going to solve for the so-called d square y over dx square, or the second derivative of y with respect to x. And I place it here. The derivative with respect to x of the first derivative is actually d square y over dx square. So substituting values, this should be the differential with respect to x, I'm following this, times, what's the value of dy dx? dy dx from this is actually km e raised to mx. Okay? We try to take again the differential of this with respect to x. K is constant, m is constant, the product of two constant will be constant. We bring it out, so that will be km times the differential of the exponential function e to the mx. So this will be e to the mx times the differential of the exponent. The differential of the exponent will be m, okay, times the differential of x with respect to itself is 1. So simplifying this one, d square y over dx square now will be equal to, okay, let's try to multiply the right hand side. K times m, that will be km square times e to the mx. Meaning the value of the second derivative of y with respect to x, or d square y over dx square, is equal to km square e raised to mx. So we now know the value of the second derivative with respect to x after taking the differential of the first derivative. So actually we now know the equivalent of this one. Okay? So I place it here, substituting, meaning we will take the value of y, then we will take the value of dy dx, and we will take the value, the computed values of d square y over dx square. We bring it to the original second order differential equation. So I place it here, guys. It will be km square e to the mx, it is this, plus 3, the coefficient is 3, times dy dx. Dy dx actually km e to the mx, it is this, minus 4 times y. But what is y? It is k e raised to mx equal to 0. That's just substitution, right? And if we try to inspect all the terms, we got a common term, k e to the mx. The first one got a k and e to the mx. Second one, we got a k e raised to mx. Plus the third one, it got a k e raised to mx. So if we try to multiply all the terms by the reciprocal of that term here, that meaning it is 1 over k e to the mx. If we try to expand the first one, okay, this will disappear. Okay, so what remains is m squared after multiplying by 1 over this. For the second term, okay, this k here will disappear. Okay, e to the mx will disappear, right? So what will remain for the second term after the multiplication of 1 over this? It will just be 3m, right? And for the third term, the last part, this key here cancels with this, so this will disappear. E to the mx, same as this, they will cancel out, okay, or this will be gone. So after the expansion, the third term on the left hand side will be simply minus 4. Okay? And for the right hand side is 0 times 1 over this. Okay, anything multiplied by 0 will still be 0. So what comes out after the so-called expansion and simplification, it will be a quadratic equation. What comes out will be an m squared plus 3m minus 4 equal to 0. This is a quadratic equation. The only unknown is actually m, the one we needed in the so-called general solution. And the computation of the roots of this is now pure algebra. You could use your quadratic equation or try to factor out by inspection. If we try to factor out by inspection, hold on. If we try to factor out by inspection, the possible factors of m is actually m and m, right? Okay. And the possible factors of 4 is actually, this should be 4 and this is 1. And if we try to check the value of the middle term should be 3m, right? So this 4 here should be plus. Okay? And this minus, and this one here should be minus. Because if we try to check the middle term, this is 3m. This is 4m rather. And this is minus m. So 4m minus m will be equal to 3m. And what is this 3m? It is the middle part. So the possible factors of the resulting quadratic equation by inspection, okay, if you are sure, it will be the factor, the quantity m plus 4 times the quantity m minus 1 equal to 0. And under the rules of algebra, to compute for the roots, take one possible factors equated to 0. Okay? So it will try to take m plus 4 equal to 0. Okay? m1 now will be equal to negative 4. Take the second factor, m minus 1 equal to 0. m minus 1 equal to 0. Therefore, m2 now, I now place the subscript, meaning it is the value of m number 2. That's the meaning of this. m2 is actually equal to 1 after the transposition. And if we try to inspect the roots, m1 is negative 4, m2 is 1. They are both real, okay, and unequal. So they should fall under the general solution under second order differential equation. That will be case number 1. And if we try to recall the formula and how to take the general solution under case number 1, y is actually equal to k1 a raised to m1x plus k2 a raised to m2x. Since we now know the value of m1 and m2, substituting, y now will be equal to, this is k1. Okay. K1, I'm just following this, a raised to minus 4 times x is minus 4x, plus k2, a raised to m2 is actually plus 1. 1 times x is just plus x. So the required general solution for this problem here is y equal to k1 a raised to minus 4x plus k2 a raised to x. That's our final answer. That is the proper way on how to solve a second order differential equation. And luckily, this falls under case number 1. They are both real and unequal. That's it, guys. The solution is just simple, and as you notice it, The requirements and how to solve the problems are actually the basic mathematics, that is algebra and trigo. Because if you do not know how to simplify algebraic equation, you're gone. You do not know how to, what you call this, factor out quadratic equation, or solving a quadratic equation by using the quadratic formula, you're gone. That's why the prerequisite of differential equation are actually lower mathematics. You should have a knowledge of differential calculus, algebra, and trigonometry, plus your perseverance on how to write legibly, writing your solution. That's it, guys. Lesson number DE38 under my subject matter differential equation. DE38, second order differential equation, example number 2. Okay guys, for those who are taking up differential equation, if you would like my long video here, please click like and subscribe. My YouTube channel is actually youtube.com/Prof. David J. De Los Reyes. Okay? Please click subscribe if you like my channel. Okay? And if you like it, please click like. And if you want to share it to your friends, please click share. Good evening, Los Angeles.